Okay, so 4-1 rate of change. So relationships that have straight lines are called linear relationships. Okay, so when we're talking linear relationships, we're talking about graphing lines like that. So this would have a linear relationship because it would be a straight line. The rate of change between any 2 points is a linear relationship. In a linear relationship is the same or constant. A linear relationship has a constant rate of change. Remember that we talked about this back a couple of units, or when we did a 7th grade unit on it. The rise over the run is the same, so therefore the line is linear and it has a constant rate of change. Okay, so look at the example in example 1. It says the height of a hot air balloon after a few seconds is shown. Determine whether the relationship between the two quantities is linear. Okay, this goes up by the same amount every time on the y and on the x. So therefore it is linear, okay? So if we get a linear, it says determine the constant rate of change. Well, it is 9 over 1. Remember we talked about it change in y over change in x, okay? So that should be on there. Okay, so looking at exercise 1. Determine whether the relationship between the two quantities described in each table is linear. If so, determine the constant rate of change. Okay, so look at number 1. The change from 10 to 18 is plus 8. 18 to 24 is plus what? 6. 4 to 8 is plus 4. The change from here is plus 1, plus 1, plus 1. So it's constant on this side, but it doesn't do it consistently on the right side. So it is not a linear relationship. So we're going to say not linear. Okay. Let's look at number 2. The change from 325 to 650 is plus 325. 650 to 975 is plus 325. 975 to 13 is plus 325. Here it is plus 2, plus 2, plus 2. So it is linear. And the constant rate of change is 3.25 divided by 2, which is 1.625. Yeah. 1.625. Okay. So it is linear, and that's the constant rate of change. I'm going to label it. Okay, look at number 3. It says, determine the constant rate of change. Okay, so we can do that. First of all, we could draw a line connecting all of our points. So it starts at, look, it goes up from 0 all the way through. And then we can find our change, which is up 20 and over 4. So that's our rise over our run. Y'all remember that? Okay, so our rise over our run. So the rate of change would be 20 over 4, which simplifies to 5. So 5 is your constant rate of change. Okay? And then it says determine whether a proportional linear relationship exists between the two quantities. Okay, so this is where that bell ringer from a couple weeks ago came into play. To be proportionally linear, like the two have to go together. Okay, you can be linear, but unless you have to be proportional, you have to go through 0, 0. So it has to go through that point, and it does, okay? So determine whether a proportional linear relationship exists between the two quantities. Explain your reasoning, okay? Because it goes through 0, 0, that makes it proportional, okay? And because it goes up, bless you, by the same amount every time. Okay, so that makes it proportionally linear because it's linear and it goes up proportionally. Are you with me? A line is only proportional if it's linear, though. Okay, a line can be linear and not be proportional, but it can't be proportional if it's not linear. Does that make sense? Okay, so look at number 4. Determine the constant rate of change. Okay? Well, let's look at it right here. It's going down, down, down. Okay? So it's going, if we do our right, we go down 8 and over 2. So it would be -8 over 2, which would equal -4. Determine whether a proportional linear relationship exists. And I'm going to say no. And why is it no?
It doesn't go through 0, 0.
Doesn't go through 0, 0. That's the key to it right there. It's not going to be proportional if it doesn't go through 0, 0. Does that make sense? Yes.
So for those questions, you just have to see if it goes through 0, 0.
Yep. If it says, is this proportional? You can say no because it doesn't go through 0, 0, so it's not proportional. Done. Okay.